Okay, thanks for joining today. And we would focus on the Agentic AI frameworks. So, what we have seen in the last session, an approach which is no code or declarative approach to build agents. Today, we go a bit detail in terms of technology, the framework that is used. And essentially, the purpose of this session is to give you an inside view, and that would definitely add to what you have learned in the last session. And then we go to the third session with um, deploying it in a more enterprise grade fashion. Like I always say, these sessions are very conceptual, backed with technology and demo, just to really instill confidence, and anybody can understand that, and that's how I'm keeping it. I generally cover concepts, demos, and leave questions at the end so that we can make use of the time effectively. These sessions are conceptual, like I said, and I give demos. And if anybody is interested in going more technical implementation, I'm happy to do that in separate sessions. I use Azure platform because that's what my background is. And having said that, these patterns and solution and the accelerators that I demonstrate are built using open source languages frameworks. So they're agnostic to model and cloud providers, which means whatever deployment platform you decide to choose in terms of hosting your workloads, whatever languages and model you choose for your GenAI application, all that is going to be applicable as is. Now, this is a continuation of the discussion that I've been having for the last a year plus. And if you see, when I started this series, I picked up AutoGen, and we also talked about agents in the early stage. And the reason I'm saying it is becoming talk of the town today, but my focus has been there on agent, and this series essentially focusing and kind of crystallizing that thinking with more details. So let's understand what is an agentic AI. Agentic AI involves having a GenAI model being used by an orchestration layer, which can really bring in the required capabilities in terms of doing certain things. And we'll see the comparison between model and agents. So essentially, this agentic AI takes the discussion to the next level, where we do things more than just automation, where we start asking application to perform actions and bring in some autonomous thinking, planning, reasoning with the help of the language model. So if you look at this picture, so you have an agent which is making use of some tools and a language model. So language model is core of an agent, but beside the language model, we bring in additional capabilities like reasoning, planning, language understanding, and workflow optimization. The idea being here is that agent is not just generating text or images in a one-step manner. It is able to take a goal and reason about the objectives, plan and carry out these tasks with the help of tools, so that the goal can be accomplished. And we'll see that in the architecture diagram that I'm showing here. So if you see, in agentic AI, agent is central to everything. It has a model which is not shown here. So assume agent always has a GenAI model, and that's the capability it leverages. Beside having the model, it has access to tools These tools are kind of, capabilities that enable agent to do certain things. For example, here you can see it has calendar, calculator, code interpreter, search. So sometimes the GenAI model data on which it is trained is not good enough, and you require some information either from searching the web or by searching private database of an enterprise, or performing some calculation, looking at the calendar if it really requires somebody's schedule to be looked at. And code interpreter is basically the capability where you can actually generate a code and execute it for tasks which are complex. Um, and the agent has a memory, both short term and long term. So typically an agent involves doing multiple steps, and it needs to really have the context kind of managed for that activities, and that's where the short term memory comes into picture, which is the in context memory. And then you have long term memory in terms of the knowledge that it requires. Like if you remember, in Copilot Studio we have provided the website URL from where it can actually access the information to build its knowledge. Like I mentioned, it can do planning, which is reflection, self-critic, chain of thoughts, sub-goal decomposition. And the most important thing is it can take action. So that makes agent really very useful. Let's look at what is the difference between a model and an agent. And just be mindful whenever we are talking about an agent, there is a GenAI model that the agent is going to use. So the agent is not without a GenAI model or language model, but essentially, in case of a GenAI model, you generate text or images, or you basically summarize text. It's more a one-shot operation with no decision making and no access to the tool. It's essentially a single step. Whereas an agent works with an objective goal to basically perform a task. It has reasoning, thinking capabilities. It uses tools and APIs. So without tools, the agent has very little value, because you want agent to perform certain things which requires execution of calling an API, retrieving the data from a knowledge store. And typically an agent will perform a complex task, and for example, LLM generating a paragraph is a single shot operation that model is good at. Whereas in case of an agent can schedule an appointment based on the availability of an individual, but also can look at other things, who should be involved, what all information, knowledge bases it needs to really access in order to achieve a task. And we'll see that in action in the form of a demo. Now, if one agent is good, sometimes having multiple agents is better. So this is an example where you have an agent being used by a user, an agent having access to knowledge sources and actions. So these actions are nothing but API calls that an agent can take in order to, let's say, book an appointment, looking at available time slots, writing to database, fetching the data from some website. All that is enabled using knowledge source and action. Now, why would you need multiple agents? So having multiple agents makes the whole application of the agent a more kind of modular, where you would like to have multiple agents focused on a very specific task, and you can actually prompt these agents, or you can design these agents to be good at something. Now, this is basically not a novel concept. It has been there in um, programming world called modular programming from last 30-40 years. Now, what it does basically, it really enables the whole agentic um, execution more efficient, because you specify tasks and prepare these agents on a certain area, and we'll see that with the help of demos. Now, that's basically the concept. Now, what I want to do now, with the help of some code, demonstrate to you the internal working of this agentic application. And there are multiple frameworks. That is basically the topic for today, where I'm just telling you what are the opportunities that are available for anybody to look at the most suitable framework for building this agentic application. And I'm going to give you a view of multiple frameworks and also help you understand that they're conceptually kind of very similar. So one of the most popular framework for building agents is LangChain. And essentially it has, like I mentioned, it has a reasoning capabilities, and it is called a React framework, reasoning and action. And we'll see that in action. So let me just, instead of talking over the PPT, let me just show you an application. So I've got this LangChain application. Don't worry about the syntax. And what I'm trying to do, I'm trying to analyze the database. I'm doing a data analyst work. Now, a data analyst, given a set of tables in a database and some problem to analyze, has to really be good at writing database queries. And an agent can really make that really very efficient. For example, so we have a database with these many tables. We have employee tables, customer, invoice. It's kind of a simple database that you require. And let's say I want to analyze data in the database in a natural language. So let's see what can be done. So that's basically what we are going to do. So basically what you're doing, you're creating an agent. That's what I wanted to share. It has a language model, which is essential, and it has access to our database tool. Okay, and this agent is of a type React, which is reasoning and action, and I'll actually show you. So let's run it. Don't worry about the syntax. I'll just show you. Sorry, I'm in the wrong directory. And chain. So let's run this. And I will actually, and this is a very good example to show how agent works. So for example, I want to find out in the database how many employees are there. So in order to do that, I need to identify what table that I should focus on, and then write an SQL command, which is the query language for relational database. But see how an agentic AI can make this process very easy. And then I'll show you the steps. And let's look at the result first. So I have not specified the table. It could be any other table, not just the employee table. And let's understand the working of it. So I said, how many employees are there? I'm just taking a simple example. So the agent takes control, and in order to answer that, first it has to really find, and that's how a typical user would also work. It will say, I want to take an action to list all the tables. So it has identified all the tables that are there in the database. And basically, this is the result of the action it has taken. It observes that and then applies some thinking that employee table seems to be the most relevant. Okay. And said, okay, it seems like a good choice, but take an action to understand what is the schema or what is the structure of the table, so that the agent can be sure. So it basically looks at the table in more details in terms of the table structure, and then say, yeah, looks like good, and also pulls out a couple of records, 3 records in this case, to be sure. Okay, yeah, this is the right table for which I can write a query and fetch the data. So after it has assured, it has said, okay, to find the number of employees, I can count the number of rows in the employee. So again, this is the thinking, and action is to create an SQL query and checking it and say, yes, the observation is this is the query, and then applies thinking that a query is correct and execute it. And as a result of this execution, it is basically identified the number of employees. That's a very simple example I just wanted to show you. Now, if we have a complex operation, let's try something which is much more complex. So let's ask a question. The question was, how many total tracks are there and what are the total numbers of tracks per genre? So if we look at this database, so you have tracks table and genres, and the agent could really do something very similar. It kind of looked at the tables, genres, and tracks, fetched some 3 records from the genre, and then 3 records from the tracks, and then applied the same React principle, thinking, observing, and then taking action. And finally, it really created the final outcome. So what I'm trying to demonstrate here, let's go back. The capabilities of an agent without really actually writing anything. So this is basically a case where an agent can understand the requirement. This is a specific case for generating SQL, natural language to SQL, or a code generation use case. And by just writing few lines of code, so forget about anything. This is the core structure of the agent that you need to really refine, and it really performs that job very well. So let me just go back to the presentation and then we'll see. So that is an example of LangChain. There's another framework, again an open source framework, which is basically an agentic framework, has all these capabilities that you see on this diagram. And what is important to understand is the capabilities it offers for you to write an application which can perform actions. So if you see here, it can connect to AI service providers. Any models providers are supported. It has memory. It can search databases, vector databases, and other products, both SQL as well as vector databases. It can connect to internet and local services. And the most important thing is it performs the orchestration. This is the core agentic aspect, and it makes use of what is called a semantic function and knitting function. I'll actually show you in the demo. So in order to illustrate the capability of an application written using semantic kernel. So I've created an agent. This is the agent which can perform actions. It makes uses of a large language model like OpenAI GPT-4, performs planning, it has memory, and this is the most important thing. So the capability of the agent is due to the access to the tools it has. The 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 number of tools would define what an agent is capable of doing. So in this case, there are two types of functions you can write in semantic kernel. There's semantic function and eating functions, and I'll show you a demo of it, and let's see. So let's look at the code. Again, you don't focus on the syntax. So essentially what I'm doing, so I have got tools or functions that agent can leverage. So in this case, I'm using an API from Aviation Stack, which provides me access to flight details, and we'll see it running in detail. And then I have another API which uses Azure Map to identify places around a particular geography. I've got another API which provides the information about weather. Now these are the capabilities which are written in a traditional coding language like C# here, but you also have semantic functions which are nothing but the prompts. And like I showed you in the architecture, both semantic functions and native functions provide the required capability to an agent. And how do you write an agent? I won't go much more in detail. So you basically say, these are the tools, the 5 tools that I'm explained, that are augmenting the capability of your agent. And this is a copilot or a custom agent that I've written, and let me just run it so I can show you how basically this agent can achieve a task. Now I'm executing this application. Let me just get the prompt, and just imagine you're planning to go to a particular location and you have number of things in the mind. For example, you planning to go to say Brisbane this weekend. You like to know what are the flights options which are available, and find it a GenAI model will not have that detail because this is coming live from APIs which are basically having access to all this flight information. You would like to know the weather, which is important. It's live information, and you want to find out hotels and like to know what are the interesting things around. And finally, you want an agent to build the entire itinerary. So that's a kind of a complex requirement. So the number of things involved, and just imagine if you have to do it on a GenAI model, you are basically doing one step at a time, and probably you won't have access to a lot of information like flight details, and all that is possible through an API or through an application. So let's ask agent to perform this task and say. So let's say how it really helps you, and this agent first going to that Aviation Stack to identify the morning flights from Sydney to Brisbane, giving you the schedule, the airport name, flight number. We did ask how the weather would be like, so it is providing you information about the weather. It is also providing you details of the hotels in and around CBD. You did ask the agent about the interesting facts about Brisbane, and then finally you wanted to, since it's a weekend tour, you really wanted to have a sort of an itinerary for your trip to Brisbane. Now just imagine if you have this kind of a requirement and you have to do these tasks repeatedly, how an agent can make the um, whole process very simple. And I'm just trying to illustrate an example. So imagine a business process which involves doing a lot of things, searching information, finding information, planning. You can also add a calendar API where it can actually, let's say if it is related to something which I want my calendar to be really knowing, so I can write an API or use an Outlook API to, uh, update my calendar with that information. That's the power of the agent. Now we discussed about agents and multi-agent. So there is another uh, use case, and all the example I'm showing are covered in my previous session in much more detail. I'm just trying to bring a perspective. So you have an AutoGen, which is a multi-agent framework, and what it does basically, and we'll see that in the form of a code. So let me just take an example which involves multiple agents. Now imagine uh, a project which has certain requirements to fulfill. So it's basically a coding project. And if you remember, when I was talking multiple agents, and I highlighted why you would require multiple agents. So if you look at it here, so we have basically a project requirement where, which is the case practically. So you have a planner or a scrum master, you have a developer, tester, and a QA. And you want a human agent to be involved, confirming every steps, because we want it to be responsible so that it is not really going and doing things which may damage. So that's how you will create a multi-agent architecture like you see here. And every agent has got a personality, instruction to perform, and then they work together as a team like we have in a project, and they perform a task. So let's run it and then show you. So this is basically the agent design aspect, and let's run it. So we have to achieve some goal. Let's take an example. And I'm just trying to be very simple here just to demonstrate. So the requirement is to basically write a program which will calculate the factorial. So let me just make it. Okay. So when we gave this requirement, which is calculate the factorial of a given number, the task was assigned to that set of agents. They basically form a group. And the planner said, okay, this is what I need to do in terms of planning. Requirement gathering, development phase, testing phase, quality assurance, and final approval. And what I have here is a human in the loop. So this is basically, if I press enter or write my comments, if it is not really working as expected, then it will change its planning and do things in a different way. So I'm satisfied with the plan, so I press enter, and QA has looked at the plan and said yes. This even provided a feedback. It seems you haven't provided any specific feedback, so QA is coming into picture. Human in the loop says it's all good, and then developer took control and build this application. Okay, this is a code which has been written by the agent application. Okay, and specifically by the developer agent. Say, okay, I'm going to write this program. These are the values that you can test. If you provide 5, the output will be 120. If you provide 0 or 1, the output is going to be 0. So the developer has done his job. Now the tester will test that, okay, and will say yes, execution succeeded because it has received the expected output for these three use cases. And then QA is going to execute it, and that's it. And the task is accomplished. So what I'm just trying to show you, if you have a simple task, one agent is good enough. Whereas if you have complex tasks, probably you may need to build your application with multiple agents in the mind. And that's pretty much, I have. Um, so there are other frameworks like Crew AI, again, a multi-agent framework where you have a crew which is made up of multiple agents. These are the agents. So you define each agent with the purpose and instructions, and you define a process uh, so, which has multiple tasks, and these agents work together to achieve that. And if I show you the code uh, for the Crew AI, again, very similar. Don't worry about uh, these syntax. So what you have in this case, you have two agents, a travel expert and a culture guide, very similar to Travel Copilot, and we'll see that running. And you define a task which will create an itinerary for a given this destination for between start date and end date, focusing on some interest. And that's basically a planning task. The cultural task is essentially to identify the cultural norms, safety tips, and any other things which are related to that particular destination. And then you create a crew. So it's like forming a team. What we saw in the AutoGen, very similar. So you have a crew of agents and have a task set, which is planning and cultural tasks, and a process which is sequential. You want it to be running one uh, activity at a time. Okay, that's how you want to run it. And let's see after running it how it really work together. So I've got a UI, uh, and let's see how this accomplishes that goal that the user. And what I'm trying to show you is different experiences, a chat-like interfaces with AutoGen, Copilot, LangChain, but you can build a UI. So let's say we want to build a 1 week itinerary. Let's say similar to what we had Brisbane, and you can choose your interest. And let's see. Now, probably you'll see a lot of things happening, but what is important is to show you what goes behind the scene. Okay, so you will see these activities are coming into action. It is generating it. You'll see a lot of things behind the scene, and in some time. So the number of things um, this application is performing using the agent. Um, it takes a while because it has number of things. So you can see here agents doing their job, they are performing. So travel consultant is providing an itinerary, and then you will see the culture agent coming into picture and identifying things that are specific to Brisbane, and hopefully we should get a result here by that time. So you see here how good it has created that itinerary between two dates, giving you detailed information. Obviously, I've not added which flight to take. I'm just keeping it a very high level. And after preparing the itinerary by the travel planner agent, uh, you will, and what has happened, it has added some uh, details which are specific based on the cultural aspect of that. And that's the agentic AI in action. You extend the capability by adding tools, and then it can actually accomplish a very complex task, which probably will take a couple of hours if somebody is doing it manually. And just imagine if we have use cases in enterprise where, let's say, you are doing a customer service where you have to connect to their interaction records, their payment histories, their account details, and it takes a while for a customer support, and then answer their questions if they have any. Whereas you can build an agent and expose it through a web channel or through a telephone channel and serve your customer better. So basically, that's the demo for Crew AI. And let's go back. We have other frameworks like Agentic AI. IBM Consulting has a consulting advantage. OpenAI has OpenSwarm, LandGraph, N8. So there are multiple frameworks. And my objective of having this session was not just to focus on one framework, but just to highlight the core concept of agentic AI, how an agent works, and how it takes the GenAI usage to the next level, where it is not just answering your queries in a one-step process, where you are doing all the reasoning, planning, and then doing all the work for achieving the task. Now you basically hand over that by incorporating tools in the form of API calls, access to database, and make the whole experience very useful. So that's was the session. The reason of having this session was to really go deeper in terms of understanding the functioning of agents as an application construct.